Welcome, and thank you for joining us today. I am pleased to introduce our architecture firm, Tiscarino, and shed light on a pressing topic, the impact of recent Washington State Energy Code updates and how this is adding increasing complexity to mid-rise construction with an emphasis on the mandate to use energy recovery ventilators, ERVs, in residential construction. In an industry where precision is paramount, code regulations are in a constant state of evolution, and energy efficiency is a requirement. We are acutely aware of the challenges faced by real estate developers and general contractors as they navigate the maze of building codes and energy performance standards. Today, we aim to explore why these new energy regulations are moving mid-rise engineers and architects to adopt coordination and pre-planning techniques that were traditionally reserved for high-rise construction and more complex building types. The implications of this shift are far-reaching, impacting cost control and project timelines. At the 164th Street Apartment project, we had to closely coordinate with the structural engineer to determine routing for the ERV ductwork so as not to degrade the structure itself. In addition, the ERV itself is no small unit. This fact alone required structural coordination to allow for room to mount the unit within the joist space. Once a solution was found, this detail was able to be repeated throughout the building. After a building and mechanical code review in consultation with the local jurisdiction, the architect and mechanical engineer were able to determine what would be required to route the ERV and ductwork within the joist space. Using the solution led to fewer or no ceiling fur-downs in the apartment, which allows light to penetrate deeper into the unit itself. Here, a radiation damper was required to allow for the solution. Once routing was determined by the structural and mechanical engineers via rigorous coordination, the architect had to verify the clearances required by code for the ERV inlet and outlet were met at the exterior of the building. A new combination ERV exhaust termination and intake on the market was used, helping alleviate some of the overlap. The ERV unit was located as close to the exterior wall as possible, which helped reduce structural conflicts. In this example, the first joist bay in from the exterior wall was sized to accommodate the ERV unit, thereby greatly reducing the intake and exhaust duct runs. In conclusion, the key message is that to ensure successful integration of ERVs into a project, it is essential to begin the coordination process much earlier than has been standard procedure for most multifamily projects in the past. Earlier involvement by a subconsultant engineer permits better integration of all the building systems, including ERVs, which has the potential to avoid costly changes in the field and schedule delays. Embracing this proactive approach has the promise of better coordination and more economical construction. Thank you for joining our exploration into this new crucial aspect of multifamily design and construction.